This is problem number 2 on practice midterm number 2. And the question is to write the molecular, total ionic, and net ionic equation for the reaction of Na2SO4 aqueous, which is otherwise known as sodium sulfate, with SrCl2 aqueous, which is strontium chloride. And again, this is aqueous. And so this is one of those, is going to fall into either one of 3 categories. We know it's going to be either a metathesis, an acid-base, or a redox process. And in order to find that, we start out with the molecular equation. So I can write either one I prefer to. I can choose. I'll start with the strontium chloride, and I'm writing it in the molecular equation form where there is no charge. They are combined together. I write each salt as an aquated salt, and it's a neutral salt. And so that plus sodium sulfate equated. Now I want to predict. And this part you can do on scratch paper. I'll do it here just to remind everybody. This is the simple technique we use. I'm going to look at the outer pair, the cation-anion pair, and the inner cation-anion pair. And I'm going to look for either an insoluble combination or some sort of neutralization reaction, or some kind of a redox process. And in this case, first I'm going to start with the metathesis, or the precipitation. I'm looking at the outer pair. I have a strontium, which is a 2+ ion, and a sulfate, which is a 2- ion. Well, in my solubility rules, I don't have an exclusive rule for strontium, and I have a rule for the sulfate. And the rule for sulfate is, so most sulfates are soluble except in the presence of calcium, strontium, and barium. So that is strontium, falls into that. So that means I can start to complete my reaction. That means I'm going to have strontium sulfate precipitate, because it forms an insoluble combination. And now I've got to balance it. I have one strontium on the left, one on the right, one sulfate on the left, one sulfate on the right, so we're already balanced. Now, what is the other combination? Well, I've got chloride, the inner pair. I've got chloride ion, chloride -1, and I've got sodium ion, sodium +1. Well, rule number 1, all sodium salts are soluble. All group 1A, lithium, sodium, and potassium salts are considered soluble. And so it doesn't matter what this is, it's going to be soluble. Plus, so I can now complete the reaction plus, and now I have 2 sodiums, and the charge is +1. I have 2 chlorides, and the charge is -1, so that means it's going to be a 1-to-1 salt. And I'm going to have 2. The 2 in this case is going to be the stoichiometric coefficient, 2 sodium chlorides, and that's aqueous. So this is the proper formula. It is not it's not Na2Cl2. That can be reduced down to the most elementary ionic formula. And now that I've written the molecular equation, I can now decompose all that information into the total ionic equation. And so I decompose each of these salts. Any aquated salt is written as the ion, and ions, separate ions each equated. And so I have 2 chlorides. And now the charge is included, with the magnitude of the charge first and the sign of the charge afterwards. This is the convention. It's the opposite when we're dealing with oxidation states. So following this convention, and I have to denote it as an aquated ion. So I've got that covered, the strontium chloride. Now the sodium sulfate, again, I have 2 sodiums plus 2 sodium plus 1 charge. And in the case of a +1 or a -1, the 1 is omitted by convention. So I've got 2 sodium plus aquated plus sulfate, SO4, 2 minus aqueous, going to strontium sulfate, solid. And in this case, please note, I was in the solid state. I'm not an aquated salt. And the total ionic equation is going to have all of the ions written as aquated salts, but this is not aquated. So this is indeed a precipitate, and it has to be denoted as such. Plus 2 sodiums, aqueous, plus 2 chlorides, aqueous. So now I've written out the total ionic equation. Now the net ionic equation is going to contain only the materials that were transformed in the reaction. So if there was a transformation, it's going to be in a different form on either side of the arrow. The strontium is a 2+ salt. On the reactant side, it's a strontium sulfate solid on the right-hand side. So it is involved in the transformation. It's part of the net ionic equation. The chloride, there's 2 chlorides equated on the reactant side. There are 2 chlorides equated on the product side. So this is not a participant. It undergoes no transformation. It's the same on the left as the right. So you don't have to draw a line through it. I'm just drawing a line through it to emphasize the fact that that cancels out. It's not, we're going to kill off. It is a spectator ion, as well as sodium. I have 2 sodium ions on the left equated. I have 2 sodium ions on the right equated. So they're spectators as well. And I'm left with, I have a sulfate ion on the left. It is equated, and I have a sulfate in the strontium sulfate on the right as a precipitate. So that is transformed. And now the net ionic equation contains only the participants in the reaction. I like to follow the convention we've been following all along when it comes to nomenclature and writing formulas. We start with a cation first, and it makes it sort of consistent. So I'll write this as strontium 2+ aquated plus sulfate SO4 2- aquated going to strontium sulfate solid. And that's my net ionic equation.